Okay, welcome to MDC 2021. We're so happy you connected virtually with us and hope that you enjoy your experience. We want you to take a second and look right, then left. On your right, you'll see a chat. You'll post your questions for the speaker, along with sharing a conversation with your fellow attendees. On your left, you'll see a couple icons from our sponsors, Couchbase and ILM. When you click those buttons, you get to visit their virtual booths and check in for a chance to win some prizes. Another point to keep in mind, if you happen to be using Twitter during a session and would like to share a quote, moment, or something else regarding the conference, be sure to use the hashtag MNDevConf and/or the handle MNDevCon to get noticed and create some engagement. At the end of each presentation, if you would so kindly click the survey button in the lower right corner of your browser and provide feedback on how the recent speaker did, we would really appreciate that. Now, let us give our attention to Chris Riley.
All right. Thank you so much. Good morning, everybody. I hope you have your cups of coffee and you're ready to go. I know that there's a lot of information out there, and these, all of these events and all the various places you can go to learn about application development can become a little bit overwhelming. So it's exciting that you decided to give some of your time. And I thank everybody at MDC for inviting me to speak with you on a topic that I'm very passionate about, which sounds very nerdy, is pipeline analytics. And hopefully by the time I'm done with my session, you will feel the same. So I wanted to just quickly start out and put you in the mindset of a hypothetical scenario. Maybe it's not hypothetical. If one of you actually gets to drive an F1 race car, please reach out and let me know. So let's assume that you finally get your chance to jump into an F1 race car and you're ready to go. You have this amazing amount of machinery and power behind you. But when you ask them if you were going to get a helmet, they tell you no helmet. You ask them where the seatbelt is, they say no seatbelt. You don't get one of those. And you look in front of you and all you see is a country dirt road. So you have all the power in the world, but how comfortable are you going to feel taking it out on that country dirt road, knowing that the faster you go, the more dirt you're going to get in your face and the less visibility you're going to have? So that's what we're talking about today, is really the impact of velocity and how you make sure that that velocity in your software development environment is sustainable. Because if you think about the last conversation you had about DevOps and application development, I'm guessing it was something about releases, deployments, automation, all these things that make you go faster. And of course, that's the goal. There's no doubt that delivering functionality to your customers as quickly as possible is the goal. That's what you're after. But you want to do it for a long period of time. You don't want to just increase your velocity and be successful at a high speed for a few months. You want it to go on forever. And so I'd argue that DevOps is not just about velocity. It is about enabling velocity in a very efficient way so that you can get in that F1, the road is paved in front of you, and you have all the tools you need to maintain that speed. So my name is Chris Riley. I am a senior technology advocate at Splunk. Basically what that means is I didn't cut it as a developer. It wasn't my forte. Troubleshooting bugs. Well, I know there's some people out there that enjoy troubleshooting bugs, but I definitely did not. So my last venture into application development was actually as a .NET developer. Prior to that, I was working on some cool OCR technology, which is a very monolithic application. But I found out very quickly that I enjoyed the process of development and talking about how enterprises enable software development versus being the one doing the development. If you want to find out more about me, you can scan that QR code and it'll get you access to my social information, as well as the various podcasts that I participate in. So let's talk about the current state. because as I speak about pipeline analytics, one of the things that always kind of surprises me is how much of an afterthought it is for enterprises. And I think part of that is, number one, building automation is exciting. Shipping code is exciting. So there's an emphasis on that. But number two, it's a strategic effort as much as it is a technical effort. And we tend to shy away from those types of things because it's not as easy to wrap our brains around and implement. Number three, most organizations don't have somebody who owns visibility. They may have people who own monitoring, but they don't specifically define their job as making sure that there is visibility across engineering teams and is understandable by everybody. So what we see in most organizations is these silos of visibility. Developers tend to be really good at understanding what happens from the point that they define a feature in their backlog and they start building and testing against that feature. Then from there, the handoff of testing into integration environments and builds and deploys, DevOps engineers tend to have a really good understanding of what's going on in terms of automation and the tools used, your CI/CD tool, your repositories, maybe your secrets management tool, all of the things part of building your applications. And then finally, it gets handoff into production. This is where your security professionals, your compliance professionals, and most often your SREs start to get visibility. So if you think about it, their understanding of what is going on in the application only happens once it's been built and shipped to your production environments. So they're missing a lot of context. Now, what happens when those individuals need to understand what's happening in the development process? They'll usually walk down the hall and become very disruptive. Developers don't like that. And that's why this matters to you as a developer, is that you don't want to be interrupted. You don't want context switching. You don't want to be ripped from what you're currently working on to firefight and just gather information you know is probably already there. And so it can be tremendously disruptive how these visibility silos work. So the way I like to think about software development is more comprehensive and holistically. And I use this term code to cloud visibility. How do you make sure you know what's going on from the point a feature is being defined to the point that that feature is running in production? And when I think about it in this context, I come up with three components or dimensions of code to cloud visibility. The first is one that we largely know. Now we call it observability. It's really the modern iteration of monitoring. It's a new way to have the monitoring conversation for distributed systems and more complex applications. DevSecOps, that's become very popular term. Yes, another term. Both of these are just other terms in the industry. The reason DevSecOps is important is not because security shouldn't already be considered as a part of DevOps. Most will argue that if you're doing DevOps correctly, you're already considering security. But the fact that it isn't. And so we have to have this term to have a specific conversation about how do you make sure security is embedded in the application development process. And then finally, pipeline analytics, which we're going to dive deep into today. And get your questions ready, please. So I think it was on the right. Your chat dialogue, get your fingers on your keyboard and start thinking of your questions. Because you'll find out very quickly that none of these are just turnkey technology problems. There's strategy elements to all of them. And for enterprises to be successful, they have to think about that. So when I think of these three use cases, observability is kind of largely known. We know how to monitor, and we know that there's challenges with monitoring microservices-based applications. We have to address that. DevSecOps, the production side of DevSecOps, also is fairly widely known. The benefit of the idea of DevSecOps is that what we already do today to secure our applications in production can get more context to support incident response. And what you'll find out is that the foundation of the first two components of DevSecOps, which is building more secure applications and securing the software factory, is pipeline analytics. And then finally, we have pipeline analytics. This is something that's not widely known. And what's interesting is it's not tremendously difficult from a technology perspective. So the first thing I have to convince you of, even before I start, and hopefully you agree, and if you don't agree, please reach out to me and tell me why, is that in the modern development environment, your software delivery chain is the meta application. It is the application of applications. DevOps engineers or whoever is responsible for building this automation are building it for the developers and the QA engineers and the software delivery process. They are nearly scripting everything today. Automation is a huge focus. Your infrastructure, I'm sure you've heard this term of GetOps, how you interact with your repositories, your pipelines, your jobs, all scripted. So this is a very simple concept, but it reforms your point of view on what you're doing. If your software delivery chain is an application, then you have to treat it like an application, as you would all of your applications, because you are delivering this to your customers, the developers. It has a set of functionality that you are iterating on, that you're improving on, and you have to make sure your customers are successful. So your delivery chain needs to be operable. Can I operate it? Can I make sure that it's up and running? Securable, just like your application, you got to make sure that the exploits, the common forms of attack to your delivery chain are protected. And if you've been watching the tech news at all, you know how big of a deal this is. There's a big story about once a week almost. I mean, there was a massive one last week, actually. And measurable. You know if you're doing a good job or you're not. These are all things we do today, and there's no reason that we can't apply these same concepts to the applications itself. And why does it matter to you as a developer? So that you can go fast. Because if these things are not in place, that's not going to happen. And so really Code to Cloud combines all of these concepts together, where we have health, security, and metrics across our software delivery chain in terms of breadth. And we have what we largely already understand in terms of monitoring, in terms of breadth in our production environments. And another lens of this, because developers like to think in terms of their stack, is how do you align this with your tech stack? So at each layer of our stack, from infrastructure, from networking, up through business logic, backend, front end, we have monitoring. We have different types of monitoring that we align with it. We have SIMs for monitoring our security. So we also need monitoring for our pipeline, because that is the one way that we can weave a thread throughout all of these environments inside of our stack. So why pipeline analytics? If you do not implement pipeline analytics and your delivery chain goes down and you're not able to operate it, no code ships. So that's a first huge problem, because one of the key metrics is mean time to value for most software delivery chains. How quickly the feature that you created gets into the hands of the customer and they are using it. So the efficiency of your delivery chain is directly tied to that. Your software delivery chain is a part of your attack surface. We've discovered that. People can get access to secrets on development machines and leverage those secrets in production environments to exploit your application. We need to speak the same language. Developers often understand what's going on in their environments very well, but aren't able to translate that for security professionals and SREs. This saves time. So if you think about how much time you spend in your job just reconciling communication, that just all goes away. If you're able to create lenses for individuals across your engineering team, they don't have to come and ask you questions. Measure business value. We build applications to support the business. We need to tie those applications to the business. Why does that matter to you as a developer? Because there's probably some tooling, some processes. You're probably at some point going to ask for the business to invest in your development process. I don't care if it's an API, I don't care if it's a monitoring tool, whatever it is. If you want to be able to justify that easily and not knock your head against the desk, trying to figure out why the business doesn't understand why you need the money, tying your delivery chain to the business value is important. Also, do you know how efficient and effective your software development process is? How do you measure success? How do you determine that you're going faster and you're not breaking things? Or you're going faster and your customers are ecstatic about it? Technical debt, we all know what that is. It's usually that thing that we want to address later when it becomes too much of a problem. Well, with pipeline analytics, you can start to reduce technical debt on an ongoing basis. It's grooming, it's healthy. It's a healthy practice to address technical debt before it becomes a catastrophic problem. And you find yourself asking your question, do we need to refactor our application because of this? And then finally, this idea of shift left security, shift left testing. You may be thinking to yourself, I don't want to shift left. That means more work for me. Well, shift left doesn't mean more work for the developer. It means more considerations and more automation happen earlier in the delivery chain before the application is deployed. You can't shift left without visibility across the entire environment because there's no way to know if it's doing anything. There's no way to know if you actually shifted left if you don't create this type of visibility. So all of these are reasons why pipeline analytics matters. And they all kind of seem obvious to some extent. And as I was saying earlier, how do we even do this? What is the process? It's not that difficult. First step is collecting the data. So you're used to collecting data from your applications. You may be using a sidecar pattern to get data from your microservices. You probably have agents for monitoring. You know what logs are. You know what webhooks are. You know what events are. All of these are the same things you use, but you just use them on the tools in your tool chain. If you're using HashiVault for secrets, there's logs. If you're using Artifactory for artifacts, there's also logs. If you're using GitLab, you have events and webhooks. There's a lot of ways to get data from your software delivery chain. So the first step is just to monitor that. The second step is to build value stream and KPIs on top of that data. So you're creating lenses, and you're going to create those lenses on auditing, an auditing lens, a securing lens, and a KPI lens. So once you start gathering those metrics, and I should say that how you gather the metrics matters a lot, and I'll talk a little bit about that in the next slide. Once you start gathering the metrics, either via API, webhooks, or logs are generally the most common ways to do it. Some tools you have to result to CSV files, which is unfortunate, but that's what you get. Then you need to correlate that data across tools and teams. This actually is the most difficult part of this. And why is it difficult? It's a data problem. It's not a technology problem. Think about the last time you made a commit to your repo. Did you include the ticket number from your backlog? If you didn't, you've kind of crippled one element of pipeline analytics. So these types of things are important considerations when you start to think, how do we correlate data together? And then finally, once you have the correlation, you build the dashboards, and you usually build the dashboards from an operations perspective, a audit and compliance perspective, and then a KPI measure success perspective. So as I said, the technology part is sort of easy, right? Some of you may already be collecting logs from the tools in your tool chain, CI/CD, Jenkins logs, for example. If you've ever looked at a Jenkins log, it's extremely verbose, has so much information. As a matter of fact, has so much information that oftentimes it's the best source of information for things like SonarQube than using SonarQube logs directly. So that's the easy part. The correlation part is hard. This is an information architecture problem because there isn't just out of the box ways to tie your ticketing system to your repo, to your CI/CD process, to what happens in production. Usually the thread is commit IDs, job numbers, and ticket numbers. That's usually how you can tie things together. As you think of this information architecture problem, it all adds to the value of the data you get. So when I talk about one of the metrics coming up, for example, mean time to recovery. Mean time to recovery can be calculated in 3 different ways. First is your ticketing system by number of bugs, bug open date, bug close date. Second is by your pipeline. You can do it by rollbacks. You can count the frequency of rollbacks. Third is by your incident response, or if you don't have an incident response strategy, your ticketing system. You can count the number of incidents, open and close dates. Those are all decent ways to calculate MTTR, mean time to recovery. However, some are better than the other. So the absolute best is incident response. Using your incident response tool to identify when an incident occurred, how long it took to acknowledge it. Well, first, how long it took to detect it, acknowledge it, and resolve it. Now, if you were to correlate these 3 tools together, your resolution increases. Same for mean time to value. Your pipeline, your CI/CD, is the best indicator of mean time to value. But if you correlate it to your ticketing backlog, then your resolution goes up. So you really have to think about these types of things. Next is the challenge of tool sprawl. I'd say more organizations than not have this tendency to adopt tools on the fly as they seem to solve one problem or another. Tool sprawl can be a big challenge when it comes to pipeline analytics because not all tools report the same data in the same way. And so when you try to reconcile that information, you run into this kind of schema mapping problem. And sometimes it's not even worth doing it. And so you have to think about that. But I will say that by implementing pipeline analytics, you can drive better tool behavior. You can help support those tools that are most effective and adopted the most in the organization by actually collecting analytics for the adoption. So at Splunk, we actually are going through an exercise of changing our repos in a large part of our engineering organization. As we do this, we're making sure that we have visibility throughout the entire process. If you've ever changed from one repo tool to another, you know how complicated this can be. You always have to ask your question, I have a new project, where do I store it? Constant. But that's why you need the visibility. So tool sprawl can be a challenge, but you can also use pipeline analytics to start to address it. So once we reconcile our tools, part of our data problem resolution, by the way, another part that's difficult in the resolution problem is naming conventions, how you name your projects in your repository, how you name your teams. If you're not consistent, it becomes very difficult to understand what you're looking at. Once we have this data and we put it all together, we get to the next somewhat easy part. Again, this is not really a major feat of technology here. We create lenses on monitoring. We create lenses on KPIs and measurement, and we create lenses on auditing. And my order here is a little off. I'm going to start with monitoring, do auditing, and end with measuring, because measurement is the thing that developers get the most excited about, but they all come from the same practice. So first, monitoring. Like I said before, software delivery chain is down. you're not shipping code anyways. So it doesn't matter how fast you go, developer. Doesn't matter how excited you are about delivering that feature. If your tools are down, specifically your CI/CD tools, you're not shipping anyways. So how do we make sure that the DevOps team is meeting their service level objectives for the software delivery chain? Something that we already do. We do this in monitoring for infrastructure already, and it's your standard infrastructure metrics. If you are on-prem hosting your own CI/CD or your secrets management or your artifact management, then you're going to use the standard use metrics for utilization, saturation, and errors to make sure that the infrastructure is up and running. That's the most typical. There's a lot of metrics out there. For the application layer, you may also have access to the data for how the application is being used. Oftentimes, this is driven by an API gateway where you're going to look at red metrics, rate, error, and duration. You're just trying to figure out if it's up and down and if it's performant, such that you know that your developers can ship code. Next is auditing. Nobody likes this one. Well, that's not true. There's some, and especially security professionals, they like this. So the audit part of this is both about securing your delivery chain and also being able to comply with audits if you're in a large enterprise. If your compliance team comes knocking on your door, they will shut everything down for weeks to get this data if you don't have it readily available in real time. But also your security professionals want to make sure that we don't have weird behavior happening with your repositories and your various tools, your artifacts, your secrets management. So you keep track of requests, who's requesting, requests by IP, how it relates to your projects and your applications. Are people using root policy on images and infrastructure? That's probably not something that should happen. Another one that came up very recently that was a really big deal is how unfortunately common it is for people to pull images from public repos. It's a very dangerous practice. It should never happen. How do you detect that? How do you detect if a developer is pulling images from a public repo and that is eking its way into production, or actually a part of your build process? So this is also part of spotting configuration drift, which is the silent killer for security and vulnerabilities, because there's a lot of bad stuff that can go from the developer's machine to production if it's not observed. Now, this is the fun one. So this is what most developers get really excited about. This is pipeline analytics. Well, first of all, I want to say that choosing your measurement is the absolute first step here before you do anything. What do you want to measure and why? There's some things that are fun to measure that you shouldn't measure. For example, leaderboards, developer leaderboards, team leaderboards, those tend to backfire. They're exciting, but they tend to backfire, and they're not always great for company culture and team culture. So you need to decide first, what are the metrics you want to measure and why do you want to measure them? What are you going to do with that measurement? How are you going to report it back to the rest of the business? Second, once you've decided that, you have to decide, is it measurable? Do you have the data? If you have that data, are you able to actually build dashboards based on that? Because if it isn't obvious, and we talk about how do you get started, if it isn't obvious, then it's probably not the best place to start. Most organizations that are successful with pipeline analytics will actually use it as a tool to motivate the rest of the team to be more efficient, to do better with the tools, to get rid of tools. And so you really need to have a quick win first, instead of trying to boil the ocean and just say, I'm going to collect all of the data and hope that I can do something with it. Once we start talking about the different types of metrics, like I said, there's a lot out of here. This is not by any means a complete list. It's missing a lot of flow metrics that can be in here. There's a lot of metrics around aging summaries of branches to decide if you have rogue branches and technical debt in your repositories. A lot of amazing things that you can do. The reason I highlight these is because they're the ones you're going to hear about the most. So the first is the DORA metrics. The DORA metrics are a set of 4 metrics, which is deployment frequency. This is your velocity, lead times to change or mean time to value, depending on how you want to look at it. Change failure rate. So how much of the new functionality did you put out there for your users that wasn't successful, that you had to roll back? And mean time to recovery and restore. What happens when something actually breaks, because it will. So these are the DORA metrics. DORA was a research institute that eventually was acquired by Google, and they've become somewhat of a standard, but they're not a standard. They're a good starting point. I like them because they allow you to have the conversation. The other metrics that I really like are work in progress. So this is an agile metric. Cost of downtime. This is a big deal if you're running a retail business. Amount of unplanned work for you developers. How much time is being spent by you on things that are not building functionality? Activity by repo and artifact. What are your most active repositories? Great indicator of where to optimize. Our DevOps team has done some amazing optimizations based on historical pipeline analytics that have decreased our deployment times dramatically. Branch aging summaries. Are there repos out there that aren't being used? Are there ones that are being used in weird ways? You have branches that don't even make sense and not consistent with the rest of the organization. So in this session, if you're asking yourself as a developer, why do I care about any of this? Because you want to deliver functionality, that's why. All of these things are things that are going to facilitate your ability to build more functionality, because they are going to keep the entire machine moving and getting your features to production successfully. And if they're not getting to production successfully, have a clear indication of why. So just to give you 2 examples. These are 2 different screenshots of 2 different views that companies have used for pipeline analytics. On the bottom right, or is that bottom left, you have analytics around Spinnaker. And this is a compliance view. So this tool actually has it for all of the views that I mentioned, but this is a compliance view, so that somebody in your audit organization or security professionals can see how the Spinnaker CI/CD process, who's accessing it, how they're accessing it, deployment frequency by month, all sorts of really cool data, but also authentications, because this is a big deal, where your authentications are coming from. On the top, I know it's top left, is a MTTR dashboard. So this is cost of downtime, number of active incidents, amount of unplanned work. Data, all data that is saying the impact of poor delivery of software, or when something breaks, how effective you are at resolving those issues. These are just 2 examples. And again, it's not very difficult to build these because the data is there. It's difficult to understand how you're going to use it. So before we get to questions here in a second, I want to give you some top considerations. There is no easy button. Sorry, there is no pipeline analytics easy button. But the reason there's no easy button is because most organizations aren't organized enough to just drop in pipeline analytics. It is not difficult to collect this data. It is not difficult to build dashboards on the data. It is more challenging to make sure that your engineering teams are naming themselves and their repos in an effective way, and that you can correlate data across your ticketing system to your CI repos, to your CI/CD, and your production environments. So while there is no easy button, it can be done very quickly once you've figured out your data strategy and you've figured out how you are going to leverage these metrics. How you deploy your applications will directly inform how you set up pipeline analytics. So a company who is doing bi-weekly deployments, or what I call potentially really fast waterfall, is going to be completely different in their pipeline analytics setup from a company who's doing canary blue-green deploys. The reason for that is because in blue-green deploys, instances can live and die very quickly, and you can have the same instances of the app, two different versions of the same application running at the same time. And so your mean time to value, mean and change failure rate metrics are going to be calculated completely different than more waterfall monolithic deployments. Automation is a prerequisite. I mean, it goes back to what I said before. Your software delivery chain should be treated as an application. To get this type of telemetry and correlate it over a time series, automation, you always need to be thinking about automation. I understand that no organization is 100% automated. That doesn't mean you should prevent you from embracing and going after pipeline analytics. It just means that you should always be thinking about how you can automate your processes, improve them. And then finally, starting with one metric can be so successful. The people I've dealt with who have implemented pipeline analytics, who've started with one metric, which tends to be release velocity or change failure rate, and MTTR is a close third, have demonstrated huge value. You may feel like you're underachieving when you just dial in on one metric. But the thing is that one metric allows you to have the conversation. It allows you to start to build on top of something. So you're choosing one metric that is high impact, low risk in terms of implementation effort and disruption to the environment, because it really shouldn't be much of anything depending on who's responsible for implementing this, which generally is your DevOps team. Once you have that one metric, you can communicate and share it. You're going to get a whole bunch of questions. It's going to be around, how can we get more? How do we change this number? Is this number accurate? You should scrutinize the metrics that you have. And that is your foundation for building on top of this practice. And it is tremendously powerful. A lot of organizations make the mistake of collecting all the data and just assuming that eventually they can create a dashboard, or they try to make the Mecca all-knowing dashboard that nobody understands. So what was this about? Again, most of you are developers. Why do you care? You care because, yes, you want to get in the F1. So you want to leverage the velocity of the delivery chain your organization has built and is building, because it's a continued ongoing effort. But when you leverage it, you want to have the right tools, and you want the road in front of you to be paved so that it's smooth and your velocity is not disrupted by needless obstacles, because that is painful to everybody. I know it's happened to everybody. If you just acknowledge the amount of times that you've been disrupted by something that gets completely unrelated to your actual code, that's the kind of stuff you want to get rid of, because your life will be better if you can focus on functionality. So that's the why of pipeline analytics. Again, first thing you need to understand is your delivery chain is the meta application. It needs to be operable, observable, and measurable. So hopefully you've thought of some questions, because I am done with the slide portion of this, and I want to answer questions because that's always fun to have real-time engagement there. Oops, green screen. Now you see the backstage.
Thank you so much, Chris. Really appreciate you. And this is a fantastic talk. Does anybody have any questions? I mean, we're open right now. I don't have anything in the chat, but you can absolutely ask any kind of questions in the chat, and I'm sure Chris will be happy to answer them.
Yeah, I guess if there's no questions yet, I have no problem kind of throwing out the ones that I get the most often.
Yeah, you want to
first
go
one
ahead and
is,
start there and do that. Sorry.
yeah, so the first one is, who owns it? Who runs it? I think the interest in most organizations comes from a lot of people, but it usually is, what is the driving factor? In most organizations, including at Splunk, the team that owns pipeline analytics is our developer productivity team, or DevOps. It's part of DevOps. If the primary concern is application security, which is coming up just so frequently these days. Then it's driven by the security professionals and usually implemented by the DevOps team. Unfortunately, developers don't ask for these metrics too often. And that's kind of the point of this talk, and why I was so excited to talk at this conference, is to encourage that, because I think developers should be asking, how do I measure how well I'm doing in software delivery? They should be going to their DevOps team and asking for these metrics, because they are beneficial to everyone. So that's one question I get very often.
All right, we do have a question that just came in.
Oh, yeah?
Yeah, so Nyan asks, what are the tools and products that you have found helpful to paint the picture?
Yeah, that's actually a fantastic question. So most organizations lead with two tools. Their CI/CD tool. So that's going to be Jenkins, Spinnaker, whatever you're using to deploy your application. GitLab. Now we have GitHub Actions, which is peaking in popularity. Those are the two common tools, or the three common tools. Jenkins logs are, if you look at a Jenkins log, it's painful, but the amount of data that's in a Jenkins log is super powerful and really cool. I've been on calls where we've been scrolling through Jenkins logs and suddenly catch somebody using a secret in a really bizarre way that they shouldn't be doing. And that's the type of stuff you can catch in Jenkins logs. If you're using more modern CI/CD tools, you're probably going to leverage webhooks or APIs to get the data, but that's where most people start. The next two most common, and it was kind of what I was saying before, are your repos, repo stats, and also your incident response tool. Or if you don't have incident response and use a ticketing system, your ticketing tool. So like ServiceNow, for example.
Cool. That's any other things that you have found helpful or anything like that?
Yeah. So to close out, what I'll say is that I know it's frustrating that part of this is a data problem. A big part of it is a data problem. You have to believe me that the benefits are tremendous. I've worked with a lot of very large organizations who have seen the value of pipeline analytics, including my own experience with our DevOps team. And so the value is there. The data problem part of it is frustrating. That's why starting with one metric is important to get over that, because sometimes you stop at the data problem, and unfortunately, that problem is never going to go away. You will eventually, at some point in time, need to measure success in your delivery chain to report back to the business, because ultimately, your organization is going to invest heavily in your development process, and you need to justify it. The only way to do that is pipeline analytics. So addressing the data problem today is the first best thing you can do. If you do nothing else other than go back to your organization and question the naming conventions of your repositories and your teams, you've already taken an amazing first step. And so I'll leave it at that. And if anybody wants to ask me kind of more specific questions about your tools, how to approach it, at this point in time, I feel like I've interacted with most of the most common tools out there in software delivery. And I haven't run into anything that has been a deal breaker as far as pipeline analytics. So I'm available. I don't know, this QR code doesn't get you there. That's a game that we're launching tomorrow, by the way. And there's t-shirt giveaways if you're interested. But the QR code at the beginning, or just look me up. I'm happy to have that conversation. And thank you, everybody. Thank you, MDC group, for inviting me. I had a lot of fun this morning.
We did get one more question, it looks like.
Great.
Yeah, I know, right? Can you give some examples of security-related metrics that are tracked?
Yeah. So top of mind, in DevSecOps, there's three use cases: build more secure applications, secure the software factory, secure production. Secure production, we understand fairly well, even though what happens in the delivery team can better inform this. So building more secure applications, which is in part vulnerability scanning and code quality scans for like SonarQube, Veracode, etc. Those they're happening But the number one thing that people are focusing on right now is access to tools in the tool chain. So you may have seen the recent news. I don't like calling out companies when there's exploits, because we all could be there at some point. Like, the world of security is difficult. It's like healthcare. Like, we could all be there some point, and it's not all our fault. But recently, access to secrets that eke their way from development into production was a catastrophic vulnerability that came out. We also know that access to repositories. So the thing that people have been measuring a lot from a security perspective is just that: access to secrets management, access to repos are very common now.
Okay, got 2 more questions right now. So
Nice.
what are the upcoming 011Y? Honestly, I don't know. Trends that you have seen.
Yeah. So I have this thing where I said, if I ever say 011Y or Ollie in public forums, then I will pay you money. And I only get to say it now because of that. So this is an unfortunate acronym for observability. Observability is the modern practice of monitoring. Why we have to make it a members only club by shortening it. By the way, it's there's 11 characters in observability until you get to the Y. That's where it comes from. And if you're really cool, you call it Ollie. What are the trends? Well, I think in observability, we understand observability, the modern practice of monitoring, has incorporated 2 new types of data: traces and spans. You tend to instrument traces and spans at a code level, either auto instrumentation or agent. This information is coming from the code to support APM. Now, what we see a large uptick in this area is that developers are on call because of monitoring and observability tended to be a site reliability engineering practice, or more traditionally, the NOC. But now with observability, that amount of data is most beneficial to the developers who build the services. So we actually see developers more and more being on call for the code that they build. I know nobody likes to be on call, I get it, but the power of these tools is to support that. The other thing we see is that observability used to only be considered traces and spans. People are thinking more of it as a strategy, where it's not just traces and spans. That's just a new type of data coming to the table to better support your application, because true observability practices includes an entire suite: incident response, synthetics, real user monitoring, APM, in addition to traces and spans. Now, synthetics and real user monitoring, for some organizations, that's all they're doing, but that tends to be the more cutting edge part of it.
Okay, and last question we have right now, at least, is why do you consider Git repo naming convention is important? What is the purpose of setting up that standard?
Yeah, great question. If I didn't have an answer, that would be really embarrassing because I harped on that so bad. So here's why. When you create your dashboards, you have to have a mechanism of filtering and dialing in. So if we again go to Jenkins logs, the only way to really be able to take a dashboard at a global level, engineering level, and then double click on application level and having a meaningful understanding of what that means is by having a standard naming convention for your projects and your teams. The reason is that backends are not deployed frequently. So a mean time to value rate for your backend is not going to be tremendously useful when you compare it to front-end applications. A global view of your environment is going to do just that. It's going to give you a mean time to value for all projects, including the aggregate of your backend. But you can't compare your backend change mean time to value with your front-end mean time to value. You can compare mean time to value across your front-end applications. If your projects are not named in a way that you can visually identify what those are, then you end up in comparisons that aren't fair. And it can, and potentially not fair to your teams, because you might be going to backend team and like, why is it taking you so long to add new functionality when it's absolutely expected, where you have a front end service that's released daily. So that's one example of why.
And I guess really it goes back to that slide you had with all the thread and stuff like that, where, having the things named properly and, getting it all tied up that way, at least at the beginning or moving to a way, if you're not there yet, really helps with that overall picture and being able to see everything, exactly. Right?
Yeah. And you can't correlate. Again, if projects are not named in a consistent way, it's hard to correlate two tools together. Yeah, that's right.
Cool. Well, you know what? We have no more questions. I think we'll go ahead and stop there. Again, Great. Really, thank you so much, Chris, for this talk. I really appreciate it. And everybody, make sure there's an after party at 5 p.m. So remember that. After parties are always fun. And also make sure and take that survey at the bottom, the link at the bottom for the survey for this. It really helps everybody out over at Minnesota Developer Conference to be able to know, what you guys thought and, how we can make things better. All right. Thank you all very much. Really appreciate it.